Hello, I'm Daniel Lindgren, and I'm the president of OcuScience, and I welcome you to our course today, our wet lab. Today, we'll be doing wet lab sessions, and we will have 3 different wet labs, and we'll cover today electrophysiology. Within the 3 wet labs, we will do a mouse ERG, both in the light and in the dark, for you can see the processes of actually doing and conducting mouse ERGs. And then I will do a session on data analysis of ERG in the second session at 12. And then the last session, we'll be doing a large animal ERGs. So in putting this course and wet lab together, we've been doing our preparation to put these wet labs together. And we wanted to show you basically what we have in terms of our technologies and try to overlay how we're trying to address the issues, the challenges with getting good data from your ERGs. So before I get too far started, I'd like to just do a few administrative items and talk through kind of the crew here at OcuScience that has been supporting me on putting this course together, as well as the wet lab. So for one here, I'd like to bring in my team over here to kind of introduce you all. So come on over. So for my team of people that have been working on setting up this course is my engineer, Trenton Motley, my son, Cannon Lindgren, and my project manager for imaging, Sean Blancas. So we've been working on this. So we just wanted to say hello to you all. And wanted also to ask of you, if you wouldn't mind here in a moment, is to share your video. We'll set this up. And we'd love to get a picture of everyone's smiling faces and a little hello, so we have that as a way of capturing this event, since we all cannot be together. And then we'll try to do a little collage of everyone here after the fact. Okay, so thanks. Now, given this is an unusual circumstance where we're doing things virtually, primarily because of the pandemic, we're going to maintain our social distance, but I want to make sure everyone can hear me. So everyone's going to stay masked up. I'm going to talk to you directly, and that way we don't have any issue with people hearing my words. We have today 42 participants, and we have people from around the world who are calling in on this Zoom session to participate. And so I wanted to first bring out a couple things for the wet labs. If anyone has any technical difficulties, the telephone number for you to call us is 866-250-3937 and dial extension 6 and let us know what problem you're having, and that way we can deal with whatever technical difficulties. Also, I want to make you aware that over this past couple weeks, the internet service in our area has dropped out unexpectedly a few times. So there is a small but a chance that we may have a connection issue. And if we do, please stay on Zoom and wait for a few minutes. And as we've experienced, it would come back. So hopefully that will be just a small blip in the time frame, okay? But if there's any problems that persist, please let us know via the phone number. If we also, let me give you that number again, 866-250-3937, extension 6, okay? Other items to cover here. We're going to come through this section here now, and I'm going to begin talking through Wet Lab 1. And what we're going to have is we have 2 cameras on our wet labs. We have, you can see, the wide shot that you see us now, and then will also have a second shot, which will be our close-up shot. Okay, and then we'll go back to the wide shot, so you can see this is how we'll be able to serve up the information. We can move the close-up camera around, so if any point there's something specific you want to see, we would like you to ask those questions or comments via the chat, and we will monitor those as we go along, and you try to make the changes and try to do the things that you would like us to do so you get the most out of this kind of visual learning experience, okay? So for no further ado, let me get right into doing rodent electroretinography. As you can see in our system here, the OcuScience system is fairly small and compact. But in general, ERGs all have some very common components. One of which is, of course, a Ganzfeld dome, the ability to flash light. This is a very small dome, but it's still big enough to do both eyes of the mouse or a rat at the same time. There are other systems with much larger Ganzfeld domes for doing full field ERGs, but this is the configuration we have. Each ERG also has a computer and an ability to turn that analog signal that's coming from the animal and digitize it so that it can be presented on the computer system, whatever the size is. In our handheld, we actually have the stimulator, the computer, and the display all built in this one little self-contained unit. Now, to talk through some of the bigger things about doing ERG and getting good results, we designed our system to try to take those things in consideration. So first and foremost, I'm going to go through the bottom bench here because these are all the parts that are actually required for conducting ERGs. So kind of working left to right, we have a temperature controller. And this temperature controller is hooked to this plate that also has a probe for keeping the temperature of the mouse in line at 37 degrees Celsius. So we don't have a thermal loss, which can affect the results of the ERG. And then secondly, we have over here our Xenotech isoflurane anesthesia system and the appropriate charcoal filters so that we're able to sedate the mouse over here in the car in our little acrylic induction box, but also keep them asleep in our face mask that's built into the table. Now for us, we have over here, we have the oxygen supply, as well as an APC. So we're actually running independent. We're not connected to any of the electrical mains. It's all being isolated in that manner. You will also kind of see that we have everything on this cart. And this is really very advantageous because now you can come and work with one animal eye on one side and then also be able to reposition and access the mouse very well on this side as well. So this is what are some of the advantages of the system. I'd also want to point out the Faraday cage. We built the Faraday cage because in our portability, you could go to different environments and have different ambient noise issues. So the Faraday cage basically mitigates the ambient noise wherever you are, and that way your data stays consistent and you don't have a lot of variation. So that's pretty much an overview of the system. Now let me talk about conducting ERGs. As you can see on the top here, I've put out all my essential items for conducting the ERG. And I want to be able, when I do the mouse ERGs, I need to be aware that I'm not going to be doing it in the light as I am doing right now. I am simply showing in the light all the components so everybody gets a very clear appreciation. We'll conduct an ERG on a mouse here to show up the setup, but later we will actually wheel the card in and we'll conduct a second ERG in the dark. So you can see kind of the environmental changes and the effect they have on doing the ERGs. But since we're working in the dark, we want to keep everything basically, I should say, in a dim red room, we have everything basically laid out so we can get the ERGs done efficiently. So we have my loops because at my age, I need to be able to see more closely than my eyes will allow me to. So, depending on who's doing it, you may want to have different types of accessories that make it easier for you to be able to see. We have tape as necessary. As you can see on the table, I have everything laid out. I have my active electrodes and their little contact lenses here. I have the reference electrodes in place here as well. I have the ground electrode in position as well as the probe. So everything is all ready and prepared for me to conduct the ERGs. Now later on, I'll be doing a second, so I have a second pair out here as kind of a backup. And if I'm conducting ERGs on multiple animals, I would recommend that you actually have two pairs. So one's being used and one's being cleaned and then replaced and alternated between the animals if you're doing multiples in a day. Having some distilled water handy with a pipette is always very helpful. This helps sometimes just put a drop on the eye to keep it hydrated, but also helps get increase the conductivity and reduce some of the impedance sometimes. So that's a nice little trick. And then lastly, I have all my anesthetics, the proparacaine, tropicamide, as well as my coupling media all ready to be used. So what we're going to do, that's basically the whole setup. Everything's already pre-connected, so we're ready to conduct the exam. So first thing I'm going to do is move our mouse from the induction box and put it into the mask. Flush. That was weird. I'm getting some type of back pressure, Trenton. Yeah, it's rising up a bit more than expected. Okay, maybe it's all well. Okay.
I've had people do it for rats, rabbits, and chinchillas. And the fun part is we don't have a low fever exam.
Okay, so now I've placed the probe into the animal, as well as I have the mouse into the face masks. So I'm basically going to go through a process of putting in first the ground, using my forceps into the back of the tail, just kind of into the skin, just right at the surface. Then I'm going to insert my references. Now I'm going to move my little actives out of the way so I have a little extra room to work with. So now I'm putting in the reference. So I would like you to get a paper towel for me, please. And I may want to switch to the close-up maybe. That might be very helpful too. Let me go ahead and move camera first. How's that look? Good.
Good mouse. Keep on breathing, buddy.
I'm going to go ahead and put the tropicamide anesthetic in the eye. I'm sorry, mydriatic. Proparacaine. Now I'm putting my loops on so I can see better the eye and see the electrodes. The first thing I'm going to do is grab the electrode ends, the threads. I'm going to try that again. Got a little.
Patrick. Oh, you're home. I thought you were outside. Oh, okay.
Let's see, two. So just to move on to what we have going on. So we go to the close-up of the rodent. We are basically now in a position where if you see, we have the rodent is on the table, we have the references in place, we have the active electrodes on both sides are in place. I have taken off the excess little bit of electrode thread, so it's all well in position. Now the mouse has been sitting here. We have a fairly close to stable. Both of the eyes are close to being, let me show you what this looks. One of the things about the system which is helpful is as you're actually conducting the ERGs or setting up, you can actually look on the screen and see what the status of the animal is. You can see on the line, the animal's very, very stable, and that the noise, even with the cage down, is fairly low. The B channel is picking up a little bit more noise. Now our eye is showing here is red because what we were always trying to target is below 10,000, and so we're actually just at or a little bit below that. 5,000 is of course the goal of what we want to do, and 5,000 microvolts is the goal. We want to stay at that or lower on the electrodes, but for the training purposes, I think we'll just continue to move forward so you can see how this all comes together. So once we have the position and everything complete, we can then now slide the animal forward and we'll put his head into the Ganzfeld dome. Okay, and then we will close the Faraday cage around the animal. Now I'll be careful not to knock any of the wires and make sure everything is settled in here nicely inside the Faraday cage. And let me see, before I move this back here for a second, before I go to close-up. How's that? Look better? Okay. So now that we have the Faraday cage and everything closed, we can actually come back, and here is now our time that we can start running protocols and collecting data. Now, since this mouse is not fully dark adapted and is light adapted, the ERGs we're going to see are going to be more or less a lot of noise because, just basically being a nocturnal animal in the light, the amount of signaling that's going on is just kind of all over the place. So this is basically the whole setup for conducting a mouse ERG. To run through it real quickly, want to make sure we have all the equipment that isolates the noise. We want to make sure we keep the temperature of the animal consistent. We want to keep the isoflurane consistent, or I should say the anesthesia consistent. Depending on your lab, you may use ketamine, xylazine. Other labs, isoflurane is standard. I think the benefit of the isoflurane is that you do have a level plane of anesthesia for a long period of time, or that way also with ketamine, there's also a bit of risk with the injection, plus, of course, the headaches of a controlled substance. The other side of this is we have collected some data, and this is all done in the light. So what we want to do now is that we're going to plan on moving this whole system into the dark, because I want you to have a sense of how it all works. Now, my intent was to actually conduct another mouse setup in the dark, but given the limitation in times, we're probably going to have to come back and do that at a later date, and I do apologize for that. Okay, so let me go ahead. I'm going to start moving system. Trenton.
בוא לפה בבקשה. לא. זוז, אומר לבא זוז. ראיתי שזה הבא. ביי מותק. יד. ביי ביי.
In a dark adapted room, and I wanted to show a few things that we have going on in here in the room when it's dark. So in terms of setting up to do a dark adapted mice, there's a few things in your laboratory you want to plan on. Number one is that you want to have a general red light available so you can navigate what's going on in the room. Okay, so now that we have the ability, let's do a quick, you can see now, let's just do a little backdrop from the close-up to the overall shot so everyone can kind of see what our environment looks like. Okay, all right, is it looking good? Yeah, so you get a general sense that we're in the red light. We have the whole system set up, so you should still be able to observe the animals as well. One of the other considerations I wanted to show, I'm going to sit back and we're going to switch over to the close-up camera for a moment.
Is there a specific wavelength for the red light?
Yeah, that's a good question. I should point out that we're using a red light up in the ceiling. That red light is actually a 660 nanometer light source. And then also the door that we are coming through is literally been sealed with insulation tape, as well as a bottom cover, so that we are doing everything to isolate any extraneous light from coming into the room. So that's, I guess I should stop right there in a short period of time. I'm just saying, leave it real quickly. Are there any questions or questions that I can answer at this time, or just kind of leave it back to anything in the chat that we can cover here in a little bit of time?
Just the intensity and the wavelengths here
Okay.
for the red lights.
All right, so that's basically all the components that go into doing the mouse ERG. If, as I say, in the setup of the electrodes, if anyone wants to see that in more detail, we'd be happy to redo that at a later time and get caught back up on everything else for the wet lab for the day. So I guess without any further ado, the intent will be, we'll stop this little Zoom session for about maybe 5 minutes. I'm going to switch over to another computer, and then I'm going to conduct the next wet lab, which is going to be the data analysis of ERG. And that's the next step of the wet labs. Okay? Yes.
Quick question, just following up the red overhead light. Does the intensity of that overhead ceiling light matter?
The intent depends kind of on the distance and on the room. I think this is like the one we are using is a 10-watt LED.
I think it's less. I want to say it's 2.5.
Oh, I'm sorry. I apologize. 2.5 watt.
Okay.
So a very low wattage bulb. In fact, where did you get that, Sean?
This actually we were able to purchase at Home Depot, and it matched up with our filter set and was in the proper wavelength when we put it on the spectrometer.
Right, and if you have any questions about the spectrum of that light, you can also purchase some red filter material and put it over the cover of the light, just to be absolutely certain. That's a good question. Are there any other questions I can answer? Okay, well, let's call this conclusion of Lab 1, and we'll give us just a few minutes to make the transition to start up on Lab 2. Okay, thanks, folks. If you should need any assistance with the course, technology, or any problem, please feel free to email us at info@acu-science.com or call us at 866-250-3937, extension 6, and we'll be happy to help you. Thank you again for attending our course.